Alrighty then, hello there. A couple of minutes early, but I can probably use that to get off to a little start by the time people show up. I have to mess with some of my controls for a moment, don't mind me. If I mean to focus on these things, I must always pause the little window on the screen that shows me so that I'm not constantly staring at that. And that ought to do for the time being. So hey, Nansen, hello. So we're going to do some TapeDelay2 because last week was all caught up with inventing the whole plugin on the spot, and I have now released that on Sunday. So time to move on. I'm a little distracted because of a bunch of things going on, like there's a certain amount of family nonsense, and there is happier and more fun nonsense having to do with the synthesizer system that I'm rebuilding. I have a meetup that I am looking to go to some point in the next week where I'll be bringing along the portable case, so I would like to get it into a condition where it can make noises. And I'm also bringing the Sleepy Circuits Hypno along with that. People might find that fun to play with. It'll be nice to catch up with people who are actually interested in the stuff that I do. But speaking of which, let's jump right over to and there we are, seems to have worked. Jump right over to the laptop with which we will code a thing. As you can see, I got a bunch of stuff kind of getting ready to do. Now I've got audio clips that I can test stuff out on. And we're going to have a little bit of a look at what we've got here. Have I started with it? Previous one was TPDL, so this becomes TPDM, TapeDelay2. And I remember bogging down on it a little bit, and I'll tell you why. I bogged down on it because the earlier version of TapeDelay is very unusual. It was coded in something of a strange way. And I can demonstrate how that is. I'm not sure if I'm going to go super long today, but should be able to put in a couple of hours. And as always, if you've got questions and stuff, this is a fine time to catch up with me and ask them. And here's what we have with our original TapeDelay. Hey, Bo. So it was arranged in a really weird way. Like the dry and wet were separate controls. Delay was right down at control 3. And then there's a feedback control and a lean fat control and a depth control. And I don't need to have it as weird as that. Also, some of the variables that I'm using are signed integer 32s, and some of them are float 64s, which is a pretty good way of doing it when the audio samples are actually 32-bit, but some of them on some of the VSTs are 64-bit. You don't necessarily gain that much in handling 32-bit values on a 64-bit computer. Hey, Lorenzo. Yeah, and Hull's going to be interesting because I feel like it should be pretty straightforward to set it up so if I'm applying it to some other purpose, and I mentioned I should be able to get rid of a possible problem that it will have and run at much higher CPU efficiency for those really long average sizes. The different averages don't have to be the way that Hull set them up to be. That is somewhat arbitrary, so I should be able to tune those for tonal purposes. And I'm hoping my ear is going to stand up to that. Like if I am modeling things against recordings off of a EMU SB1200 and going like, how shall I make this particular Hull style steeper averaging filter and dial it in so that it resembles the sound that you get out of that, I'll probably be able to tune the factors in a useful way. But speaking of useful ways, let's get this together. I think I'll start by just taking everything. Yeah, as far as having a low and high pass in one plugin, what I'm actually thinking about, Bo, is I feel like the stuff that I learned with Hull and those particular filters would be well suited to making into a simple 3-band EQ. Possibly a fixed frequency one, and possibly more of a bit of a parametric, or at least one where you can move the cutoffs. Because the thing about using a multiple band EQ with this type of technology is that you can make it in such a way that it acts kind of like dry-wet controls, and you can always sum the bands together in such a way that they are bit identical output. So if you, rather than run everything through their own bands and combine them, what you do is you make your top 2 bands out of the low-pass filter and then dry minus the low-pass filter. You add those together and you get dry back again automatically. And you make the lower band be your already filtered mid-range to lows, and then subdivide that as well, and then add those together to get the mid-range and add the highs to get the dry again. You can keep going with that and still have a situation where anything that you're doing with filtering can zero out to effectively straight wire audio. It will not sound like it's even running through an algorithm, because you're doing it all. I'm thinking of calling it CSG EQ. CSG is a term in computer graphics rendering. It's constructive solid geometry, and it's kind of that Boolean stuff. It's kind of making things by subtracting them from each other. And the trick is, if you're starting with dry signal and then do all of your EQ bands by further subdividing and subtracting low passes and such, then what you'd get is something where if you notch out one of those frequencies, you like take it to 0, and then combine them all back again, you'll have the dry sample again, just mathematically, just by virtue of how that works. And it doesn't matter what characteristics the EQ has if you're doing it that way, because no matter what the EQ is actually doing, the band that's done subtractively is just the literal inverse of it. Reason I use the MIT license instead of something like GPL v3 is the MIT license is more lenient, and you can take it and use it in GPL v3, but you can also abuse it more easily, and that is more likely to have people actually using the stuff, which in fact is happening. I'm still hanging out from time to time with the Surge Synthesizer folks, and they are using my stuff on a pretty regular basis. They really enjoyed Galactic when I came out with that. And anybody else who wants to use it and builds, basically the way the MIT license works is you can just about take it to closed source if you wanted to. The thing is, if somebody was to do that and nothing was really stopping them from going like, oh yeah, this is the credit, which is what they basically asked for, and here is where you can find the source code that I got this from. That opens them up to basically being competed against. So if somebody decided they wanted to do all of my plugins but with GUIs, and we're going to do it all in Juice or whatever, and then they were going to charge money for it, they would be able to do that. And it would be kind of like the, gosh, what the hell is the name of that? Ardor. Ardor is an open source project, and you can build it. It's just that it's really hard to build. And if you download their binaries have like copy protect, well, not exactly copy protect, but sort of serial number stuff, and they want you to pay. And it's a mechanism they can use because they are still making it completely possible to build your own version without their serialization stuff, without their copy protect style stuff in it, but it's just very hard to do. That's why I'm using the MIT license. It is not just about source openness, it's also about whether this stuff gets used in the wild. And if you allow your work to be exploited by people, then it will become, it's the same as the music business, honestly. In the music business, the folks who ended up getting the big names were either the big sharks or got the most exploited. And that's basically how that works. Like, you can still hear Creedence on the radio, but if you do, John Fogerty's not getting any of it. It's like that. So it's an intentional choice, and it's also a choice that maximizes stuff sort of going into the commons and being usable in such a way that, like, my analogy there is very much that it's like, do you want to be the Beatles or do you want to be the Velvet Underground? The Beatles, everybody wanted to buy the records and go to their concerts and stuff. However, the Velvet Underground, the joke there is everybody that went to their concert started a band. That's more or less what I'm after. So that's why I'm doing the more permissive MIT license. And you can take MIT license stuff and integrate it into GPL stuff, which would make your offshoot of it be a must-stay open source and must-stay GPL v3. I am entirely down with that. I think it is great if people do it. All of the angles on that kind of stuff are kind of weird in some ways. Like, you got VCV Rack. I'm still sort of half interested in doing a being able to support VCV Rack in my plugins. I haven't been really jumping on it because the guy is kind of hostile towards M1 Max, which I moved towards in a striking way and went to a lot of effort to make sure I was supporting it. I think that is the future of where Macs are going. and is in general a good thing. And there are some people in the VCV Rack community that are so mad at Apple that they're like, oh, it sucks, it's terrible, it's awful. And I think that's affecting their development. Plus, VCV Rack is being affected by the fact that they want to branch over to a more closed source. I don't know how far you would go towards calling it closed source, but they want to do a plugin version of Rack by which they can be paid in the more normal way. They don't want to go, the Patreon style way that I'm going, that I believe Analog Obsession is going, where it's all about making your project be as high profile as possible, and then people will just donate to it if they can. I've done the commercial software thing, and when you do that, you can make more money than doing the open source Patreon, not demanding money from anybody ever kind of stuff. You can make more money going commercial that way, but it's sketchy, it's bouncier. You put out a big product and it's a big income for a brief little while, and then everybody pirates it or whatever, and it goes away and you have to come up with something new. And I just found that was not good for me. Either as a person or as a audio. I'm clipping out. I'm getting too loud. Let me dial that back. There we go. So it was not good for me to do the commercial software thing because it was affecting what I did, and it was also the up and downiness of the profit motive. The fact that you'd have a hit product and it would be huge, and then you wouldn't know whether you had another hit product coming in the next month or the next year, was a lot more stressful. So yeah. Let's check where I'm at. I did that. Now I need to move some of this stuff over as well. That's not the one. This is going away. This bizarre thing being done with a signed I don't even know how that worked as a signed integer. That don't make a lot of sense to me. I would have thought uint would work for that better, but whatever. Oh, I guess I see. Wow. Boy, that's a weird algorithm. Yeah, I have seen Mirack. I think I may have actually downloaded it. I'm going to be following up on that. Because the thing is, if I can find, you can see with the stuff that I do, you can see with the stuff that I do that I'm very interested in synthesizers and things, although I don't have enough energy to pursue them as much as I'd like. I'd like to be diving into this stuff more. I don't generally have enough time. I have very little time to record music or any of that, and you'd think that I would, but turns out that doing the plugins, I am maintaining a faster release schedule than most people, and have for a bunch of years, and that is somewhat unusual, so maybe it's not surprising that I don't have loads of extra energy for everything else. Although I would point out, I'm continuing to pursue some of my other projects, like this, which is now sheets for when I make the progressive rock card game. I've been pursuing that, and that takes many hours as well. And what you see here, which I haven't done music on yet, I've got 4 examples now of stuff that I rolled up using this technique. I played the card game until I had a sequence of types of arrangement, meaning sad full goes to sad calm, switch over to cruel angry. Cruel means weirder chords and more inaccessible, and angry is just loud and bombastic and stuff. Cruel angry is like, okay, think crazy King Crimson outbursts of wacky, outrageous stuff. And that switches to kind calm, which is enough of a polarity switch there that there's 2 slashes on the lines here. This is how I score the game. And that goes to cruel empty, that goes to cruel angry, so there's a common factor and there's a point for that as well. We set up these cards and write these down and decide by the cards, which have time signatures and stuff written on them and keys written on them, both musical notes and things like Phrygian, Lydian, minor, major. And I've got a functioning way of looking up what notes you have accessible and what keys you have accessible, or modes you have accessible. So that is also coming through with this. They've put many hours into this. This is you seeing it when it's not actually done, and I haven't had time to do actual music with it. But that's the goal, that's the direction. And the styles here also come with time signatures, but as you repeat them, you start to get where if you have 2 instances of kind calm, this green one of these is marked 7/4, one of them is marked 4/4. If both of them are on the table as cards you're playing in your track, you get to pick. And you pick either 4/4 or 7/4 and assign that to everywhere in the song that came up. You've now made a choice as to the time signature of this green kind calm passage that you return to. And you get to do that for all the different colors as they show up. They're all going to be repeating sections that are like restatements of the theme. And so you're picking, like in this case, it's purple is 7/4, blue is 3/4, brown, which is kind full. It's like a thicker, heavier, denser section. That's 4/4, and kind calm is also 4/4. So you get an extra point for repeating a time signature because that makes things a little more accessible, seeing as it can be such a pile of progressive. And you get a point for every time a color repeats. So like cool, angry, here it is again, another point there, here it is again, another point there. And you get a point for every time a transition repeats in either direction. Blue, green, green, blue counts as a point for that has repeated. Red, green, and then green, red also counts. Or red, green, and then red, green again would also count as a transition. You can see it's drawn between the two. And you write down the repeat there. And that also becomes a check mark, an additional point in the scoring of this thing. You could play this as a game where musicians sat down and worked out these arrangements and with their decks of cards, or you could deal out hands using a single deck of cards, and then you try to put together like who gets the most points of this hand. There's this gamified aspect to it. And then when you've got that worked out, you pick what the time signature is. Again, if the time signature repeats, that is also another point. And it's got written here B, and up here it says major, down there it says Phrygian. The way that works is as you're playing these cards, let me get 2 cards so that I can hold them up. You're playing these cards like this. So the one has a time signature written on it, and as you get multiple ones showing up, you get to pick. If you only have one, you're stuck with whatever time signature that was. And then underneath it, where it connects to the other card, is a F, which is a musical note. You could play it along in those cards, absolutely. It's a very different style, but it's also a thing that one could do. And then let's go and find one where it would continue. Let me see. Not those. How about this? There we go. So you'd have this sequence where we've got actually a 7/4 and a 7/8. You could call that the same time signature, honestly, but it goes through here, and you would add up all of the letters that came, and those are the notes you have available. There's, like B flats and stuff as well. And then, as you can see, it goes up, and up here major is written, and then it goes down, and down here minor is written. I set it up specifically so that you'd pick all of the directions where the note didn't go. So if you're figuring out what things are available from this little sequence of cards, this goes up, so you don't pick major, which is from here, you pick Phrygian as a possible mode. And then instead of, it goes down into this, and that is Mixolydian, but the one that was not chosen is sad column 4/4 up here, and minor is written next to that. So the available options you have are Phrygian and minor. And then if it went up into cruel empty, it would be another minor. And so that starts giving you, let me pick this up again. You start playing this out, writing these things, at which point you then have a list of chords and a list of modes that are the available ones that you can use. And this makes it easier to come up with chord progressions, as I've done in these columns here. So you pick your key and mode, and then you make some little chord progressions. I took a guitar and I'm like, okay, what would work here? Here's a D minor Dorian. I used the slide rule to look up what chords are available. And I went, okay, D flat minor, C, and let's go back and forth between that and then go to a B, and that's a 7/4. And then I transition to another one. It's also in D flat Dorian, although I can switch that around too, and I made that go from E to, I could play this for you. Would you like to hear it? That might be a little bit of fun. This guitar might be in tune. Close enough to the electret mic anyhow. So yeah, what I came up with when following this entirely through is a worked out song. I'm not going to have it all exactly right off the top of my head, but this is what I got. Was let's see, D flat minor, so the 7 chord comes in from the slide rule. Note that now it's an E minor instead of an E major. All out of tune. Back to the D flat minor again. So this is into the cruel angry one, so it's kind of based on something like that, and it's a 12/16, so I never really came up with a riff for it, but it does that. Into Kind Calm. Kinda like E major, but not really. Into a gray section, which is cruel empty, and it's back into the it's D flat Dorian this time, which is where we started. And so let me, yeah, A flat minor. That's this mode. That makes it interesting. Back into the Cruel Angry. Man, I'm clipping out like mad on this guitar. Didn't realize it was going to be that loud. I'll play more gently. Back into our sad calm section. Note it goes major to minor. This is the brown color. It's kind and full. So there's a denser arrangement. Over to kind and calm. Back to Cruel Angry, and over to Sad Full, which we began with. So there is one example, and again, this came out of playing with cards. I've got another example here where I never came up with chords, and then I got a couple of more which might have interest to them. Like here's one with some yellow colors. Yellow is meant to be happy empty. So this one started out sad full in 5/4 in E minor. It's exactly the same key, although this time it's E minor rather than D Dorian. And I can play a D major there. I don't have to always play the D7, but I can. It goes into an A7, which is an A Mixolydian. Now let's see, where is her? Okay. A sad calm section. And then our happy empty that I mentioned is a F sharp minor. And it's arrived at by jumping up to B7, going down to A7. So and that's a 7/8. I'm not exactly sure how that goes together. This is just the raw bones of stuff. And it repeats those things and goes back to an E major played as an E7 for the very end bit. And yeah, so these are all kind of coming out the same way, but if I sequence them and program them into the synthesizer, they'll start sounding different because the chords are coming from a different instrument. me strumming this makes them all sound the same because they're all strumming. See, here's one that the previous one, the available notes were A flat, D, E, F sharp, and G, and it was major, minor, or mixolydian. This one, the available notes to start on were B flat, C, D flat, E, F, and G. And the available things were major, minor, Locrian, mixolydian, and what I call fifths, which is a option that you're trying to avoid thirds and do more power chords and stuff with it. So this one became another 7/8. Going into a major there, green, calm. Oh, here is an interesting, I use this to go from one place to another. So that's a purple color, that's sad, full, so there's more of your minors in there. And I use the chord slide rule to travel. Between majors and minors on the same notes, like there's a D minor and a D major in there. And it's just sort of switching between those. And then I get into one of those yellow colors, happy empty. I seem to have B flat, C7, B, C7, so that's interesting. Maybe it's meant to actually be B flat there as well. Or maybe I had it in mind as like or maybe it was a B minor, I'm not really sure. And orange. Back into the red section again, and then so yeah, this is a lot of these. When I was writing the chords, I had a riff or something in mind, and I could play it, although I probably was playing it on a different guitar, and it sounded like a thing when I had it. That's the challenge. Is I'm a little distracted because this is still coding day, so I am going to be returning to that. We've only spent about a half an hour talking about this, and it's not really enough for me to dive into it. Plus, there's also the possibility that I can't do this in live stream at the same time, whereas I can code plugins in live stream at the same time. So as far as the chat is concerned, let me glance that over. One of the things I have in mind is doing this and having stuff where you can interpret it how you please. The whole idea is you should be interpreting it how you please, and in fact breaking the rules as far as picking which chords to use or whatever, as long as it's coming out with something that sounds good, because it's a constraint. It's a way of like wedging things into a format where on the one hand you're scoring them so you can have a more highly rated arrangement sequence that follows certain rules that are probably going to lead to like having different kinds of transitions is going to score better than having all the same transition over and over again and then something else for no reason. You know, there's purpose behind some of that stuff. But it's mostly about being short of ideas. It's mostly about a way of getting things into the zone where you can do something with them. Let's bounce back to this stuff while we're at it. Matt mentions, I'm working on getting a Mirack filter that uses the same chip. Yeah, that is the thing. I have actually placed an order, because it's not as expensive as a real 1200, for a Doepfer filter. Not any of the ones that I have. I've got a 124, which is the WASP filter with the 4049 or 69 chip. That's the WASP filter is the one that blows up if you put voltage through it wrong. I've got 103s, A103s, which are the Zoxbox sounding or 303 sounding filters. And I've got a A108, which I'm not all that excited about, honestly, that is more Moog sounding. But there is, if I'm remembering correctly, the A105 SEM filter. That's the chip. And I think it's a decent chance that it's actually the real chip, because apparently there's a lot of these out there. Electric Druid no longer has them, but for a long time Electric Druid had literally the SEM chip that was made and put into the EMU SB1200. It's a known kind of synth style chip, and those Doepfer filters, and the reason I jumped in and got them, well, they're still available, because I feel like at some point they're going to stop being available if those are indeed ones that use the genuine old school chip. That's not in the circuit of the old sampler. But if it's the same filter chip, that's significant. That means that I can do things like take my chord organs and radio musics, which is do-it-yourselfer music thing modular module that you can get. And I strongly recommend it. And that's a 12-bit chip. And a teensy processor. A teensy is this little bitty board that you can make stuff out of, and you can use the raw output of its processor, and it's capable. It has audio libraries, and you can do like tones, and you can work with samples if you use the firmware from the radio music, and do all these various things where it is spitting out digital audio. It could be sampled digital audio, it can be tone generators. You can make it run at a wildly elevated sample rate, but you could also make it run at the same sample rate of the old samplers, and it's 12-bit. That's what the SB1200 is also 12-bit. And I've heard a number of people, like notably I think Chad Clark from Beauty Pill has talked about this, that say that the 12-bit stuff just kind of sounds especially nice. And the stuff that I've done working with like my radio musics, I've been real happy with how those samplers sounded. But those are the raw output of the chip. Exactly what you'd get if you had the old like SB1200 but then didn't filter it. And the SB1200 did that, had very likely the same tone quality as the 12-bit output of a teensy. maybe a little different. I guess eventually I'll see. And then it followed that up by darkening it with a voltage-controlled filter, which tracks to the sample rate, and that's the tone. The tone of the SB1200 is this 12-bit sampler, and the 12-bit sample played back, but then they're using a synthesizer filter to do the roll-off for the when they've pitched it down, in other words. And it's always in play because it's something like a 26K sample rate rather than a CD 44.1K. So all of this stuff, like you could tell the teensies and the radio musics to be running at this SB1200 sample rate. That is completely doable, or any variation thereof. And then you could take the Doepfer A105, if I'm remembering correctly, which is that SEM filter, and then you'd have the literal chip inside. So I feel just like people haven't put these pieces together. That this is just a thing that exists, but people haven't really figured out, oh hey, if I put this, DIY kit sampler into this very affordable for Mirack purposes Doepfer filter, as near as I can tell, that should pretty closely replicate the sound of one of these old unobtainium samplers in hardware. And then it's a matter of continuing to work on being able to do it in plugins. But I would like to be able to do it in hardware because I don't do much with sampling, but I have done some things. Some of the things that I've done are like the stuff that I've done with my samplers is essentially switching around weirdly with recordings of my voice to make sort of sound effects there, or getting like background noises and things, or just taking breakbeats and switching them around. I came up with a special way of using breakbeats where I haven't really pursued it any further because work, and it's not just work. I've also been doing like car repairs and things like that have been really eating up my bandwidth. But I got breakbeats into the machine where I can be re-triggering them and switching them around, and was to the point where I was getting some nice things out of them. And that's without the filtering. If I took those same breakbeats and then threw specifically that one Doepfer filter, the SEM-based filter, which is the same chip that went into I feel like I could be incorporating some of this stuff and getting the vibe of it into a zone where people would really reckon, oh, dude, did you get one of those classic old samplers? Actually, no, I didn't. I got about a little over $200 of modules that happen to do the same thing. Those are the things I enjoy. But let's get back to some of this other stuff. Don't mean to spend all afternoon talking about this. Oh, and by the way, there is no master plugin good for loud sausage music. Never make loud sausage music. Seriously, just don't do it. It's bad for you. A saturation plugin probably shouldn't make a loud pop at the start of tracks after rendering. I don't know. I guess it would depend upon which one it was. If it's one of mine, then it might be worth looking into it in case there's a bug fix. That kind of thing can be produced by, like, see what we've got here? We're looking at the code for this. And yeah, I've got to switch over to that. Like if there's values in here like this, where we're doing stuff with these saved up things, but up here, we didn't initialize the variables. That can cause either crashing the DAW or whatever, or it can cause a loud pop that stops, the loud pop goes away afterwards. So it could be some kind of uninitialized variable. Now, while I'm talking about it, let me get some of this stuff up and rolling. Boop, and mentioned the Mirack filter. Yeah, Doepfer A105. If I remember correctly, because I just ordered a couple of them because I have high hopes for what I might be able to do with them. That is, I believe, the same filter that went into SB1200s. SB1200 has a known synthesizer filter that is one of those ones that they made. They went into some of the Rolands and things like that are integrated circuits. They're a filter on a chip or an oscillator on a chip. And the SB1200 has a particular one that's a 24 dB per octave voltage controlled filter without all of the available options of some of the other chips that were out there. It's a smaller, more limited version, but it has a particular tone to it. I've listened to comparisons between the original chip and some reissues that are out there, and I thought the reissues of this hardware chip were okay. They were maybe not exactly spot on, but they were pretty close. The reason I jumped on getting a couple of those Doepfers is I have a feeling that since this is not a completely obscure part, but it's now gone into the reissue land and stuff, I feel like there's a decent chance that the Doepfer modules used new old stock of this actual chip. In other words, there's a possibility that the Doepfer A105 literally has exactly the same chip in it that the classic sampler does. If it's a new old stock from the same manufacturer, made off of the same die and built in the same way, then that would mean that you could buy the chip out of this like $9,000 sampler. It has two of them, mind you, but you could buy the chip out of the $9,000 sampler for about $140 as long as supplies hold out. And you can also buy the raw chip, except for you can't, well, you used to be able to buy this original chip from Electric Druid and they ran out, although they sometimes still have them. And there may be other places. I think the stocks got bought up by manufacturers like Doepfer, who were building a product using it. And for a while there, it was extremely available. And then they ended up all getting bought up, or people bought them up to put in their own stocks, and now you can't get them anymore. So that's the idea. I will find out, because when I get this Doepfer module in, I'll take it apart if necessary so that I can look at the chip and see if it's actually the one. The reissues are probably a decent way of doing that for those who can't get a hold of the real one, but very much what I have in mind is being able to work with, teensy based samplers. In other words, this little thing that I've got in the radio musics and such, the module that you can build for about $90, and you can buy teensies for about $20 to $30 or so. Although you need to also connect them to an SD card to really work with samples effectively. But I've already got the output of those working really well for my purposes. Like, I'm very happy with the sounds that they create. But I also, even though it can make things like bass tones and so on and so forth, you always get a degree of kind of digital grindiness because there's no actual filter on the output of these guys. They're just the raw output of the teensy chip, and it's 12-bit. It's good that it's 12-bit, but it doesn't really come with filtration afterward. And so if I get some of these filters, I can probably do everything that I do, and rather than just running, like I do a bunch of stuff. Yep, I'm not surprised. So I just bought a couple of them. Perfect Circuit might still have them. Or they might not, because I just bought a couple of them. But that's what I expected. And that's the whole point of the exercise. And currently I run my Teensy based stuff into various other kinds of filters. I've got a Blue Lantern filter in there. I've got a couple of different kinds of Doepfer filters without this particular chip. And they're very nice that way. Like I run a bass oscillator into a Wasp filter, and I'm very happy with that. But doing actual work with samples and stuff, I'm looking forward to being able to run that into the correct filter from out of the SB1200 and maybe get a particular vibe out of that. Because if I don't, I'm just doing the raw output and it's a little more gritty than it has to be. And if I use a different kind of filter, that's all very well and good, but it's not the particular combination of the 12-bit digital oscillator output and this particular filter chip. And again, Matt Daw, I guess that implies that they're using the new old stock ones. So Doepfer were using literally the same chip. But they do make other variations of that, and people are doing reissues of it. So if you're talking about, I think you mentioned getting into the ballpark, find one based on the same design. Find an SSM style filter, because Doepfer's not the only one that's made them. I've seen kits, I've seen stuff, I've seen kits where people compared the real vintage chip with the reissue chip. And I think there's reissue chips that are the smaller form factor rather than double inline pair. There is going to be ways that you can get into the zone for that. But I see that Doepfer, if you can get a hold of the Doepfer modules, used or new, it sounds as if they have literally the same vintage chip, which is, I'm happy about that. That's why I jumped on them and bought a couple of them, because I was like, I bet I can use this. I bet this is going to be relevant to my purposes. Anyways, back in, because bear in mind, if I get a hold of this stuff and actually find it useful, those are the things that I can put into plugins. Like the whole EQ method might be useful for replicating data. I thought that there was some similarities between what whole sounded like and what the old samplers and this particular filter sounded like. I'm not saying it's necessarily going to be exactly the same, but I think there might be. I'll find out. I'll find out, because by the time I get this stuff in and get to work with it a little bit, which always takes some time, I'll be working with audio off of like breakbeats or whatever, out of a 12-bit sampler through this particular kind of filter. And if I can do that, I can take reference sounds and throw them into the computer and then go, okay, now what do I need to do in order to get some plugins to mimic this sound, because now I have the sound. But let's dive into this a little bit too. I'm very much not happy at all this nonsense. This seems like a big waste, so I'm going to not deal with all of this. But I think I might grab some pieces of it. Like, let's take that bit. We don't need this. That sounds like the kind of thing I would use. A bunch of this is really old code. This is why I'm going to be doing it over again. Yeah, I know, I do need to make progress on the plugin too. I mean, it's a nice problem to have when you're interested in enough different kinds of stuff that you're kind of all over the map. I've showed you like what I've been doing with the card thing, and thanks to the Patreon, I should be able to move forward with the card thing once I've done the artwork for them and all. I'm actually working on some plugins for lo-fi production, And I've got a variety of things like bit glitter. You might look into that. So let's see, this is the stuff I'm going to ignore. This looks like a big pile of mess. Let's grab just a little piece of this. I'm going to see whether I can make just an echo happen, and then I have very different ideas as to how this should be done. So that's a sort of complicated arrangement for moving the delays around. That's filtration in a really, really weird way. I feel like that's super messed up. I don't even seem to have distortion in here, which is interesting. I feel like that's something that's going to become useful. This is going to be pieced together from a whole bunch of different things, I gotta say. And of course, since it's Airwindows, you still get to use it. If the things I'm taking out of this are stuff that you liked, then you can go back to TapeDelay and use that. But I feel like I can make it a lot more sophisticated and have better range of tone coloring. Let's steal that too. Oh, hello. Here's an extra sanity check for some reason. There's our feedback effect. Here we're incrementing things. And let's just, this is a strange way of implementing it, but it might work. Let's see what we get. And we're not going to need this. And that seems normal enough, I guess. And we're not going to need these. Very interesting. Reusing that. Let's not. Let's make it just local. Yeah, Macity might suit you for lo-fi stuff. There's also Mackie Q. The whole one is not necessarily emu filter. It's just something that I found that might be handy for that. It's certainly not emu filter all by itself, so I'm going to correct you there. Let's see. How about we just take this away now? Goodbye, TapeDelay. We're ignoring most of you. At some point I'm going to see whether I have anything that works. Take this out. Take these out. We've initialized them. Let's quickly build this and see whether we have anything that does anything. That's an interesting result. Oh, did we actually use the guts of this? Yeah, apparently we already put that in there. That's weird. Okay, somewhat unhelpful, but whatever. All of this stuff goes bye-bye, and we're not actually using that. And this stuff all becomes just generic. We may be using 6 controls, we may be using more, but one thing we do have to change is the stuff here, because we're now trying to set stuff that doesn't exist. So these things never got updated. We didn't get that far. Now if we build that, some of this is still not working, so we're going to find out. Yep, there it is. And we're going to leave these things as being not used. Now they're all not used. And we still have some more problems. I'm too distracted talking about all of the other things. Oh, we forgot to, there we go. And that will now work. And we don't want this. We want to do the calculation rather than keep a separate variable because it's cheaper in modern computers to do the calculation and only have this one variable sitting around. We appear to have this in 2 places. Why is that? Because we're applying this here. Okay. So dry wet is literally doing the same thing as this. So what we're going to do is comment this out for the moment, because it's not useful to us right now, seeing as this is being used for this here. And now if we build this, it should actually build. Nope, not quite. We'll call this, well, it's the last one. And let's see now. We can get rid of these because we're not actually using them. None of this is getting used, so the delay becomes 3. Let's change that. Undo. Delay becomes 1, feedback becomes 2. There, now we've got some other stuff sitting around waiting to be used. And with a bit of luck, this will either work or it won't. We'll find out soon enough. It did build. It warned me about stuff, but it built. So now let's see whether we've got something that actually makes anything happen. We'll use one of my reverb testers, snare silence. And if we try to use it on this, either we'll get an echo effect or it will just break or die or something terrible will happen. Let's see what we got. I've also got it set up to feedback louder than when it came in. So let's see now. Set these to sort of intermediate values, this to full wet. We have a working delay. I feel like the adjusting of it might make bad results. Yeah, see, we made artifacts there. So that's not always going to be good. I don't know whether the previous one that I did, it might be. Well, let's test this out. So I've got that available. Let's see what happens when I try using the original tape delay, such as it is. And do we want to keep this stuff or not? So here's the original tape delay. Very impressive, obviously. So dry and wet all the way up. We've got no feedback, we've got no depths, it's not doing anything. We'll set lean fat to exactly 0. Okay, I think it's doing something now. But maybe it's not. Okay, this is a weird beast. You can also make it feedback. So you're supposed to be able to change the pitch. The weird pitch moving thing is having to do with the way that it originally implemented this. So the drr there is not actually what we want. That's just what the original plugin did. It's supposed to be able to do these pitch bendy things, which it's not really able to do. I have got what.txt in all the downloads for the categories of plugins. And they have about a line of text for each of them in alphabetical order so that you can look at what the plugin does and have a single sentence where I say what it is. That's the best I can do. So that already exists. So what I'm wondering now is, this is my maximum delay. Can I implement this in a way where the right isn't necessarily, like, can I use all of this delay buffer, seeing as we're going to be undersampling it anyway, so that if you speed it up, we're basically writing it into the buffer in a way that's more useful? And I don't know the answer to that question, but this is a fine time to find out. Firstly, let's make feedback be just 1 so that we can have infinite regeneration if we want it. So we do have this functioning. It is a kind of delay, but it doesn't use all the stuff that I had before. So int max delay. Let's change some of this stuff around a little bit more too, because we've got it pretending to be 1 second of maximum delay. And that seems legit. But I might want to make the actual definition of the thing just a bit longer so that I can treat it as exactly 1 second. There, if I do that, then my delay line can be the exact 44100. So here's what we're going to try to do. Delay minus minus is the point in question here. So what if we made this be you will probably see what I'm doing with this once I actually start doing it. I've been thinking about this one for a while. If I can do it correctly, it will mean that I will have the full range of pitch weirdness as you would have on a real analog delay. And that may be worthwhile. And I'm just initializing more than I'm actually going to use. I never like keeping it really tightly. If you have a single sample that's left over that you didn't count up right or whatever, then you can have problems. So I like allocating a little more memory than I'm actually using. It's silly, but it's what I do. I think that works. Does it work? Let's see whether I have an error there. Oh, hello. Well, that ain't right. Oh, I see why that is. I need to fix this first, but this part worked. When it says invalid types, you can't have a floating point number in an array subscript. Yeah, Emma, I'm glad to see that you're enjoying Hull. Cool. The Fibonacci number just turned it up being the golden ratio. No, this isn't going to have Fibonacci. This is going to be something else. So what we're doing now is changing this around a bit. We don't need that to be in the brackets. In fact, let's just be a little rude and make this be all a line. Just 'cause. So we've got that. Don't need to worry about this. And we're no longer using max delay for anything. So here's the thing. See where we're going with this? Rate equals get parameter param1 times 10. As we move this down, and there's some things I'm going to need to do here, but as we move this, instead of going one sample at a time, we can make it move faster. Delay minus equals rate. We can simplify that. Since it's no longer one at a time, we need to cross over the edge more linearly. It's not actually the way to describe that, but still. And I feel like no, I am not bringing iron oxide to tape's updates processing to TapeDelay2's feedback loops. But I'm bringing some things with them, like I'm bringing the undersampling when I get this initial stuff working. And I'm trying to do something I haven't done with any of these plugins before. We'll see if it works. It's taking up a very small amount of space for the time being, so there's that. Don't need this up here. We don't need these while we're not thinking about them. We don't need that comment because it means nothing. Build it again just to clean up some of these errors. There we go. Comment that out. There. So what we need to do now is this. We got this. It is float 64. Store delay equals input sample plus deep pause divided by feedback. Maybe I'll do an interim version of this, one that does not work, so you can hear what it does when it doesn't work. That might be good. Let's see, rate always has to be 1. Actually, no, it doesn't, does it? I say let's find out. We will run this and see what terrible noises it makes, and then we'll fix it. In theory, there should be a way of setting it up where delay is always meant to be negative. Let's first see whether this works at all under any circumstances by setting it to exactly 0.1, forward generation. What do we got? There. So we're hearing the full dry wet does actually seem to work. So 0.5 is just good for this. Now what happens when we start moving this around, we will take it off of the 1 sample per cycle. We are now moving through that sequence faster. But as we recycle, this is what we want out of this behavior to some extent. However, let's take it down to lower than the real speed. You'll hear what happens, which is going to be something kind of weird. So what's happening now is we're listening to a scattering of samples. They're roughly the right samples, but at 44.1K, they are like the ones that we're hearing are in a row. But then these slowed down ones are spaced out. They're not interpolating. We're just hearing a sort of scattering of samples, and that's why it has that funny tonality to it. And we'll speed the entire loop up again. Everything that we hear when we're laying a new sound in, it's going to be either exactly at the sample rate, or if we're running much faster, it's just putting samples at these spaced intervals in order to be able to go. Or if we're running much slower, we're just not going through the samples fast enough. But this is what we're shooting for with this peculiar behavior. Is something where we can do this with the pitch. This is like what an analog device would do, and if we could layer stuff over this in the same way, that would be desirable. So we've actually got something already. Here's what we need to do in order to, well, that's not aliasing, that's an ugly effect. Maybe I can demonstrate it. How about I show you what that was? I'm not sure I can. Let's go back to that and set it to a much faster rate. See, I don't think I can do this because what I need to do to demonstrate this is play it, that's not aliasing. That is individual samples being spaced out in a peculiar way. It's the sound of the snare hit. But each individual sample in the snare hit is like 5 samples apart. So if I was able to show you this, which I can't, because I can't move the control while it's processing, so I can't render it to a file. what you would see is individual samples all spaced out. Like, let's say, here's what the waveform normally looks like. But what it would be is, you know, like this sample and then a bunch of 0, and then this sample and then a bunch of 0, and then this sample and then a bunch of 0. What I need to do is keep track of it so that it can interpolate between the samples when they're being recorded at very high sample rates. So let's dive into that and see whether we can make something happen. Fun to try to make something happen. And the way I'm going to be doing that is we've got delay, which is the position that we're running through. And it's an array, so it's only a discrete number of samples in there, which I'm moving through at different speeds. Turns out I can move through it slower than reality. And I can also move through it so fast that it's only placing a scattering of samples. I need to make it so that if I'm running really fast, it interpolates between the last place I was at and the new place. Or we could simply do a digitally sounding thing, which is repeat all of the previous sample until we get to the new one. But I can do better than that. Linear interpolation should work fine. And what's the word? The word is pause. We're saving this as prev pause. We're initializing it. If I can spell. Yep, it's aliasing with gaps between the points. Nailed it. So at this point, what I do is this little line of updating everything is hang on. I don't need this here. We can just take the raw output and that'll be fine. Fine. And then I can put the real dry wet back. It does the same thing. Cool. There we are. So we're making input sample B the output of this. We're grabbing one instant in this string of samples, but we're moving through the samples super fast. Maybe. Sometimes we're moving through the samples super slow. And apparently that actually works, so yay. But in fact, let's have it always be moving at least a little tiny bit, and let us also gotta love my power. There, so rate can be a little bit more easily manipulated, I believe. It's going to be harder to tell what unity gain is, but we don't actually care. Strangely, this also is giving us the capacity to run at garbagey low sample rates with low fidelity and have it be extremely extended. That's interesting. I didn't actually plan that, but cool. We'll see how well it works, I guess. So, we're making pretty good time. It is only 12:32, and we have audio and stuff that sounds like something. So here's the deal. Let's start it with a more primitive way of doing things. Which direction is that going? Delay gets smaller. Therefore, priv pause is either going to be bigger or it's going to have a problem in the wraparound. But we... Okay, let me undo that. Go away. So what are we really doing here? Now I did this. This is probably wrong. And let's make this comment go away because that's from something else. Let's put a little space in so that I can have space to look at what I'm doing. Hey, Joss. So what we need to do here is previous position is where we were last. Then we're incrementing it. So delay is one figure here. And we're storing input sample plus our feedback. And we don't actually have to have the feedback as far as thinking about this, but it'll be a thing. Well, rate is 10 max. So that ain't happening. Rate can never be 44,000. So where are we at? Basically what I need to do is keep the previous position, and then as we are installing new figures from store delay, which is input sample coming in, plus the feedback effect that we've got, we need to be not just putting it into this, but we need to put it into all of the new numbers coming in. If we make a big skip, if delay is jumping ahead really far, like we've got this and then we jump ahead really far, we need to continue putting these in. And that means our wraparound matters. So these get broken out into new lines too. This is what we're doing, and this is what we need to be doing. Input sample equals D pause is the output. We can always just take that directly from where we're at. We could interpolate it too, come to think of it. But the writing of the new figures coming in, every time we generate a new array number and write that in, we need to be doing that. Let's see. I may not actually have to keep this. Let's take it back out again. I feel like that's not the correct way of doing this. This is the hard part. I've not coded this one before. Yeah, well, it's the rate of stepping through the samples. That's why I called it rate. Could be something else. Could be speed. We'll call it speed. There we are. So now what's going on here is dpause equals store delay, right? That's our input sample. We've defined it as what delay is going to be, so that's fine. We can do one of these with no trouble, but we need to keep adding them. So the way this works is going to be tricky. Because here's the thing. We need to be continuing to increment pause here, like d pause -1 and so on and so forth. We're instantiating it here so we can do anything we want to it while we're fooling with it. Like we're placing the new value in here, and store delay is the new target. That's actually a problem too. I want to say sample or something. We'll do that. We'll say sample. So if we do this, everything is still the same. This will all still work as the same delay unit that it was before. Input sample equals dpause is after everything happens, so that part's fine. We'll move it down here. That is the output, which is always going to be an instant in this interpolated thing. Pause equals for delay. That is the beginning of this process. New sample equals input sample plus dpause times feedback. That is also fine. But what's going to happen is we need to be able to make it so that every step of the way it assigns one of these. It'll start with the previous one. And then every step of the way it will step pause down by 1 until it gets to what the new target of delay is. Unfortunately, delay doesn't necessarily end up being less than what it previously was. It can be plus 44,100. However, we do have a so this is going to be the integer version of what this was. So we can do this separately. Check this out. Does the same thing. So at this point, our output is at the new target. We're definitely applying speed by the delay because that is what lets us have more fluid motion on these things rather than having it only pitch change by integer variables. This is also why we can have slower than real time. But we need to step through pause and apply these samples. So let's just make prev sample be new sample again. Where do we reach our target? We reach our target when pause equals floor delay, which is something that we just impose later, but I'm going to live dangerously. So this is going to already wrap, okay? That means we could be stepping down, or we could suddenly be plus 44.1K, plus 1 second. This is part of the stepping. This is part of this. But if we move this down here, this may do interesting things, by which I mean break. So, in theory, what this is going to do is, and there's no bailout condition, so if it goes wrong, it can crash completely. But we are getting a new sample coming in, but we're not actually going to be dealing with that. Delay minus equals speed. So we can use this speed factor as part of our calculations also, but right now we're not going to do that. Here's our information coming in. And while it is not reaching its target, because int pause equals floor delay, this is going to go silent if it's always equal to floor delay, because we'll never run any of this. But this should step through assigning everything to the new sample, which is previous sample. The interpolation is going to come with this, but let's see what we've got. Bunch of ugly mess that's ticking me off, so let's see what it does, if anything. Maybe it's not going to do anything. Maybe it's going to blow up my speakers. We'll find out. It ain't doing nothing. How about like this? Nope. How about like that? How about like output of the function? How about no delay? How about much faster? Aha! All right, that time it worked. I know what happened too. Let's see if we can fix this. Check it out. If this never runs, this never happens. But if this happens, then we will always have something, even if this doesn't run. So let's play with it again. And again, we are not interpolating yet. What we're doing is like the equivalent of a nearest neighbor algorithm or whatever. It's just sample and hold. This is purely sample and hold. Hang on, we ain't even there yet. Slowness. Wait for it. That is sample and hold. That is no longer the little sputtering of ticky noises. Now it is a sequence of delays, and the sample rate has been dropped to next to nothing, but the high excursions are still there, rather than being a scattering of points. So that part is working. And we can go up into high frequencies too. So we now have a pitch adjustable delay doesn't need to go as slow as this though. Over 1 second, where we have complete range of adjustment over this. And a delay. So, next thing is let's do the interpolation. So here's how that works. We're going to keep this deep pause equals previous sample because that's what we do at really low frequencies. but we also continue calculating it out this way, seeing as it is working and all. So let's see now. What we want to do is base this on speed somehow. Our maximum speed is like 10x. So we're covering 10 samples, but rather than stepping along 10 samples, we want to each time add something. So we need to make that step closer to output sample. Let's take this away and put this here, just to kind of finish it off, just so that we know we have the correct value when we're done. But what we're going to try to do is, this is the one that's coming in. So increment is new sample minus previous sample. If increment needed to be exactly 1 to get us from the one to the other. So if speed is larger, then we divide it. We can also do a sanity check. Can we do a sanity check that is, we could do 2. Wait, that's not even what we care about. Hang on. We could just try it, see how it blows up, see what crazy things it does. My problem here is that if speed winds up becoming a tiny, tiny number, then we don't want that. I'm not going to want increment to become huge by being divided by a tiny, tiny fraction. Under those circumstances, new sample minus previous sample is going to be, let's play with it and see what it does. It's going to make a horrible mess. Let's see what kind of horrible mess it makes, because I'm stuck and I'm not sure what it's supposed to do. What kind of horrible mess do we get? We get this. Oh hey, that wasn't as horrible as I thought it was going to be. Well, I assumed this was going to be a horrible mess, and it's totally not. We are hearing something going on there, but I was expecting it to blow up much harder than this. I hear something in here that's not right. Let's see what happens when it passes through to the next iteration. Yeah. See, this is what I was talking about. The crackliness here. It shouldn't be this crackly. That's what I was complaining about. But this part's working fine. So let's see what we got. Seeing as the rest of this is working fine. We need one speed and we need increment speed. Hang on. Alrighty. Now let's see whether that does what I had hoped. Now we got increment as new sample minus previous sample, but it's limited. It doesn't get to become a huge number anymore. I'm surprised it worked the first time. I would have sworn that would have blown up with a big mess. Maybe it'll blow up with a big mess now. I think that sounds a little rattly. Like, surely it should be smoother than this. Yeah, that's more edgy than it should be. I hear so many high frequencies in there, that can't be right. So what's going wrong? So new sample minus previous sample should give me the amount of difference. Ink speed is limited, and it should give me the amount of distinction. We start with this and apply it each time. And that should take us back up to where this is. The question is that doing it? Do I maybe need to subtract? Let's find out what happens if I do. Otherwise, if it's wrong, it'll go the opposite direction and be bad. There is a correct polarity for this and an incorrect polarity. And the incorrect polarity will be much brighter because it's starting at the same place but going the wrong direction. Let's see if that is what this is. Oh yeah, much worse. So I had it right the first time. So why are we getting these funny increments? I can't render this in a way that moves the control, and it needs to move the control to show me what it's like when I've recorded something fast and playing it back slow. So I can't actually work with this very effectively. I got to kind of think it out, or at least figure something out. Much of this is actually working. So new sample minus, this does give me the correct direction. Divide by ink speed does give me about the right amount. Maybe I need to go One more. Let's see what we get out of this, because there's some kind of offset. It's not lining up nicely. The interpolation isn't lining up nicely, and I have no way of looking at it. All I can tell is what I hear when I'm listening to it. Although there's another way to test that. So this should be doing linear interpolations, although there is a point when I say linear interpolations, I mean it is making basically triangle waves between positions. We might be hearing that, in which case there's nothing wrong. That's just what it sounds like. Let's limit the super low speedness of it a little bit. And this is being called many times between each sequence, so I can include a control here. So will we find, that has nothing to do with any of this. So will we find a spot where they connect more nicely? Also, what happens if I didn't have this? There's a question. With this, we're just chasing we never actually get new sample this way. So let's see what we get. Instead, we are only pursuing it without reaching it. That might be just the trick, for all I know. We shall see. So, now we are only chasing this, and this is the amount of additional factor I have going on here. And we'll start at a fast sample rate and slow it down. So something's wrong here. In fact, it stopped. It got stuck. How badly? So this means something is going wrong. We're never actually forcing it to go to the... maybe this is what's going on. Interesting. So we've got a funny sound happening here when we go below 1. And then the closer I get to... that's actually bad. See, it dies when I do that. But if I have it like this, not a good sound, but it's acting kind of better. It doesn't like being at this low speed at all. Maybe allowing it to do the low speed is just a bad idea. Although I do note that the adding the 1 here is good. Oh, hello. If we have resonance, if we have feedback less, it starts making other problems. Interesting. Let's do a couple of quick changes. Let's assume that our increment of speed does need to be 1, because it looked like that was what it was doing. Speed can also always be 1 or more. At that point, it will never go into that slowed down version, and we're using our full rate at all times. Which also means ink speed can never be slower, which probably means I can skip this. If speed is never lower than 1, that stops being a problem, like ever. So we stop having incredibly slow delays, but on the other hand, it behaves itself, I believe. Let's find out. What have we got here in our dense little chunk of sound? And do I ever need to have this line of code in here? Let's find out. Maybe not. Oh, it would help if I increase the resonance. That sounded more like what I wanted. I think what we need to do is find out whether I can assign it to the raw input coming in and have it still be basically that sort of deep like if I make this one change, does it still have basically that deep sound, or do I have more high frequency artifacts coming in? Let's find out. Oh, interesting. We've gone all dark now. And I know why. I know why. It's because we went up to a very high pitch and it was resampling it as it was regenerating. Oh yeah, this sounds right. And there is something that I can do with this that'll help. Although for fun, let's listen to exactly what we've got here on, I don't know, something. What would be good? drum tracks. We have not done the undersampling yet, but undersampling is going to help. We're more than twice as fast as it would otherwise be. We also might be able to expand the range of this. This is such an old computer. Let's see whether we can double that. Let's give it 2 seconds instead of 1. See whether it's still happy. And here's our next magical trick. Bet you can guess what I'm going to do next. Bandpass filter. And all of this is going to live within undersampling. So this is the chunk that lives within undersampling, and what's a good recent project for that? What has I been doing lately? I had a bandpass going on in Bright Ambience 3. That's what it is. So we're going to first steal that, and then we're going to apply it usefully. So for starters, these things are all going to be used. Feedback, not so much. So that's the plugin. This is the undersampling and the filter, except for that this is not a stereo plug. The other one was, this is not. And we'll instantiate them. Like so. Unstereoize them. Not so worried about that right now, Jess. You'll hear what I'm doing. Odd choice, but okay. Strange flex, but all right. Back to bright ambience if I can make that work. So here's a whole bunch of stuff. Let's use some of it. That's undersampling code. That is not, but this is filtering. I'm going to throw that in the same place, but we're going to make it adjustable later. Oh, why it says feedback amount. None of that relates to anything. Since none of this relates to anything, we are just going to straight up replace it with one of the controls. We'll call it 2, 3, 4. And we could probably do this. We need to edit a bunch of this. That's fine. It's just busy work, not a problem. I can do it. And that needs to be changed too. There. So we'll start with the frequency being this. Will be thoroughly adjustable later. Oh, hello. Yeah, that's going to be weird. We'll leave it. We'll leave it. It's a little messy, this. And then let's grab this. We're doing a whole pile of changes all at once. Hopefully to good effect. It'll be nice. I've run longer than I really anticipated, but that's okay. And here's one of our filters. And this is where we put one of our filters. Everything is going to be re-indented later. And everything needs to be updated this way right now. And now it's bandpassed. And now we will take the end of this and that lives here. Format, reindent. Should do us some good. Oh dear. I'm going to have to do a bit of work here. Let me find a place where this is not this. This part was fine, but the rest of it is a pile of mess. I do not want one. Yeah, I don't want this. This is going to be a big pain. That part's fine. This part is super not. So where do I have? Certainly not bright ambience. You sir are not helpful to me. So what do I have? Goodness gracious me. Well, what did I do recently? Iron oxide 3, iron oxide something, iron oxide classic 2. Oh, look at you. You look much better. So, grab this and replace this big pile of mess. Oh, but I don't have averaging on this one? The hell? The actual hell. Or do I? Am I just misreading that? I'm too tired. I've been going for too long. Let's re-indent everything, build it, and see if it even is a thing or not. I might have just lost control of the project. That'd be sad. There's my re-indent. Did I lose control of the project? Kinda. Not all that much. So, what the flying fudge? Why is it not declared in this scope? Will that be fixed if I build again? Nope. Oh, that's from before. I moved that. Regen goes through this filtering, but that needed to be defined here. That's what it wanted. Alrighty, so well, shucks, let's get rid of that and see what we've got. Sounds like a crazy tape delay to me. And 3 was going to be frequency, but currently it's fixed. And here's where it gets interesting. 4 is narrowness. Okay, that's weird. Something's wrong here. Got another idea. So, first of all, let's make this be all the same. Just 'cause. Last ref. Do I have last ref in here somewhere? Yes, I do. I want my filtering. I had it from somewhere else. Let's just do it the hard way. I'll take it from bright ambience. I don't know why it's not in the other one. But I've got everything else dealt with. So this is just going to be cumbersome. Cumbersome, but tolerable, I hope. I am going to have to figure out why it was doing that thing. Oh, look at that. That's weird. That's not supposed to be there. That's what that's supposed to look like. And now we've got this. So I can do my little stepping through things very quickly. And I can just take this away. I could have left these all labeled L, wouldn't make any difference. But now it's correct. Oh, it's not going to be syncable. Nope, nope, nope. Not going to be syncable. And I have a feeling about this. Why does it say these things? Oh gosh. I know we want this to do. Want this to do this. We're not getting enough of what we need. Did I just copy and paste that without editing it? Darn it. I'm talking gibberish, but that's because this is the hard part. And I am losing steam. But I think that's going to be some use. Honestly, it'd be better if I was taking it on the output. Can I do that? Can I do that? Can I take it on the output? Be a lot better if I was. Let's try. Oh, we don't want two of those. I wonder if it's still working. I guess we'll find out. Let's find out whether this is still working. What else can I do? I can make it go up faster, and I can have a lot more range. And we can have slightly too much feedback. And we can put in the pitch control that I'm not hearing yet. Nope. Okay, this ain't making no sense at all. I don't see why that should be there. I'm confused again. No. Well, I know this needs to be this, so let's make this be this. 20 hertz is the limit. Now let's see whether we wreck the joint. Dude, as far as detune, look into glitch shifter. And triple spread. Do triple spread. What do we got? Oh, I see what I did there. That's intense. Oh, it's because I have the speed up all the way. Here's a variable speed tape head. Here's our regeneration. Here is the frequency, which is dependent upon the resonance. Gonna need to reweight it. Maximum resonance. Sort of grungy or oldie sound. Dry, echo. very resonant. Oh, I just thought of something. One more thing to throw in here. Actually, a couple, but resonance definitely does not need to be this much of a power factor. Widens out much too fast there. This, on the other hand, much needs to be rearranged. Oh, and we don't need to use get sample rate because you know what? This is inside the undersampling. That was by design. I knew there was something wrong with that. I knew there was something wrong with that. It really kind of needs to not have that in. So I fixed it. Only infinite feedback, I think. And we'll do a power factor there too. What the hell is times? Oh, okay. That's just scaling it up. So, even higher power factor in there. What else were we doing? Let's move this so that they're in order. And change it to be parameter 5 and put some labels on these things. That should be the correct labels. I knew something about that was wrong. And okay, what broke? Something broke. Oh, I know what broke. I know exactly what broke, and it broke big time. We can't be scaling it like that, but that was dividing it by a really big number. Lucky it didn't blow up in my face right then. So figure 0 needs to not be in the thousands. Instead, it needs to be 0 to 0.5 or near 0 to 0.5. Oh, Jas, man, I hope that you're okay with that stuff. We end up seeing it up here too. So big old range of movement there. Near zero to near Nyquist, which is being undersampled, so it's always going to be. And then resonance goes down real low. Does it need to go down this low? I don't know. Let's see what it feels like. There, now it's not going to freak out. We hope. He says, optimistically. Play, be free. Okay, that needs to be way smaller. That's not going into the lows at all. Although I gotta say it is sounding plausible. I also don't think it's regenerating either, and that's wrong. That's a big problem. That's a big problem. That's not supposed to be doing that. It's like I get to choose between two different levels of this. I should have stuck with the figure L and figure R after all. Well, I know where to find it. I don't know if I like this. I don't know if I like this. I don't think I do like that. So new sample going in is loading stuff into the delay bank. I'm filtering on the output of the delay bank, but it's not touching the regeneration, which is unacceptable. So if I take this out, see, the reason I wanted to do that was so that I could filter the output of it. Maybe I'm going to be wanting to double filter it after all. Oh, so frustrating. Yeah, so frustrating. So move this here, and then it is inside the regeneration, so there's that. But we're not filtering the output of the regeneration. But I could just simply average 2 positions on this, and that might be of some help. Not really, though. Frustrated. I'm so frustrated. What the hell is going wrong with all of this? Arg, 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 arg. I wanted to do the right thing. I could just put in another filter. See, what else was going wrong? This sucked and was terrible. And I'll tell you why. I didn't have enough range of low frequency stuff, and part of that is because I didn't have it going down to a small enough number. So let's get rid of all that super high frequency crap and lean it down, and now we're filtering within the regeneration rather than not within the regeneration. That's some really tight resonance. So this is what you get without so much resonance. And remember what I missed. And resonance on the regeneration only. This needs to kick in. I need to have 2 levels of it. So I need to have 2 levels of that, and I also need to have my dry wet work the same way that Galactic and Burbity does. That was the thing that I missed. Let's jump on that while I'm thinking of it. Too many things floating around at the one time. That is how that is implemented. And the other half of that is up higher. When I say up higher, what I mean is elsewhere. Come on, open up, damn you. Up here. Keep the comments. Make this go away. There we go. And now I need to go back and I'm going to do this separately. I'm not going to dig back into the other thing. I'm going to get into this thing. Firstly, let's change all the names. We'll call it that. That's more sensible. Then now I got to change all these. Everywhere it's found. That was simple. Then we double these things up a little bit. Oh, goodness gracious me. There. And let's just say that the regeneration cuts back on the resonance less than the overall filter. What that's going to mean is they're going to have different resonances. So regen filter becomes this. Hang on. I am concerned that this is not going to work the way I think. Yeah, I gotta do this all twice. Dang it. Dang it, dang it. How about... How about we do this the hard way? Yay! Except for it's not that hard of a way because, watch. Yeah. And hold down Option to get in selection. There we go. So we're kind of doing these all over again, but we don't have to do literally all of this all over again. Because we don't have to do this over again. And we actually want, I see what to do. We can make it really narrow and then widen it again. Much more range on the wider resonances. You can even put it to insanely much range, but that's probably going to be fine. And then what we're doing here is regeneration can go quite high, so or let's be even sillier. Let's do a golden ratio variation. Yay. Just in case that means something. Gotta love it, right? So the output filter is going to be tighter than the regen filter. So we get the quality of it, but it doesn't jump on the regeneration so hard. You'll hear what I mean when I actually make this work. And regen filter, all very well. Yes, yes, fine. And where did I get? Here is where I got. Boop. I'll reuse temp sample. And this will be our output filter instead of our regen filter, which is on the regeneration. Alrighty, does it build? No, it doesn't. Here's why. We can reuse these things. Now does it build? Yes, it does. We're almost done. We're almost there. Ran longer than I'd like to, but this is for a purpose. When I get into doing stuff like this, I want it to go right. There, now if we have it very resonant, it's got a more vibey quality to it. very wide frequency range of adjustment. Nice kind of rockabilly echo. And at zero resonance, we have a nice full range, but it's still restricting in the ring edges a little bit. We can use the super wide resonance to sort of weight it. Like, this is a brighter kind of echo, but you're still getting the lows in there. And then this is a darker echo, but you're still getting the range in there to some extent. And then at high resonances, we get the extreme effect. Yeah, it needed to have both those filters in there, and I think I've got them set up right. I think we win. This ought to do nicely. Okay. You may have it this coming Sunday. Should be pretty good fun. I'm done for the day. Gonna make my dinner and be done for the day. Very good. Talk to you folks later. Bye-bye.